All right, 13.3 Kp. It says equilibrium of gases in terms of pressure. Oh, now the worksheet, this ought to be another one of those hopefully fairly short lessons, I'll say, hopefully 30 minutes or less. And the worksheet will be kind of a little bit longer work, but it won't take it that long. I mean, it's not too bad. Do number 1, 11, 12, and number 16, and then right below it, I think that's supposed to be 17. You just got to write the K expressions. So you're going to find that the homework is a little bit repetitive of what you've seen before. In fact, on the back, if you want to, I said the back, number 16 and 17, if you want to just do the every other one, the odd ones, you can. If you feel like, hey, this is just a busy work. Because it is going to repeat something that you saw in the previous lesson. But it's just, the equilibrium is so important. You can't get too much practice on these, But anyway, this is not a hard thing. Okay, so 13.3, again, it says 13.3 Kp, equilibrium constant. Now, I already told you about this, that you can write the K expressions in terms of molarity. It's called K or Kc. Oh, by the way, your textbook, or at least the problems that you're doing came from an old Zumdahl textbook. Your textbook might have changed it a little bit now. I don't remember by looking at it. But when they put a problem like this, K, this is called Kc or Keq or just K. All right? But Kp is definitely only the pressures. So when you see molarity, brackets mean molarity. It's K, Kc, Keq. But this one, Kp, is when the pressures are in it. So I'm going to probably use, I might use K and Kc. I'll use Kc and Kp. All right. So letter A just says, write the expression for Kc and Kp for the following reactions. So it's a lot of review. NH3, and I think, who knows if we even did this exact one. We've done it through all the problems, been working over and over again. So Kc means NH3. Oh, no, sorry, N2, always for products over the reactant. N2 molarity to the first times hydrogens cubed over NH3 molarity quadrado squared. Now for Kp, what you do is you put everything in terms of pressure. The partial pressure of nitrogen times the partial pressure of hydrogen, which I'll put Q, over the partial pressure of NH3, which I will put squared. Kp and Kc. The other one, I don't know if I want to do all of that, but H2I2. So the K, for part 2, I'll just real quick just show you. So the Kc would be Hi molarity squared over H2 times I2. So you don't have to put ones there. I usually do. And then Kp would be the partial pressure of Hi squared over the partial pressure of H2, the partial pressure of I2. So you don't have to put the parentheses, but it just kind of looks better, doesn't it, to have parentheses down here, because look at this, especially when you have a number like a squared there, is that Hi squared? It's kind of better just to have that. So I'd recommend doing it. And because you're going to soon be putting numbers in those things. Okay. Now this section talks about relationship between concentration and pressure can be derived from the ideal gas law. Well, guess what? We don't really have to worry that much about this anymore. It just talks about subbing P over RT in for all the molarities, and then you'll end up getting, you can turn a Kc into a Kp. But you know what? This is an equation that has been, I don't want to say, it's been discontinued from the AP formula sheet. So when it's discontinued from the AP formula sheet, that tells us that it's not very likely to be asked on AP. However, as I always remind, they have discontinued other formulas before from the sheet, like the real gas equation. But then one year they gave an essay, like a short essay, and they gave on the essay question on the FRQ the real gas equation, and then they asked you something about it. Or like in a multiple choice, they could do it. So, given this equation, I do want you to know how to use this because it's easy, and you're going to see it in college as well. And here it is. This allows you to translate Kp into Kc or Kc into Kp. And what you do is you plug in the R. Yes, that's the gas constant. And it's the pressure. It's 0.0821. And the temperature, guess what unit the temperature has to be in? Kelvin. And delta N, remember change in N is always a change in number of moles. It's the final moles of gas. Or how about this? I'll put product, moles of product minus moles of reactant. And when they used to have this on the AP formula sheet, they said, they gave you this, it said where delta N equals the number of moles of product gas minus the number of moles of reactant gas. Or gaseous product, gaseous reactant. So they actually told you what N was, all right? How to calculate it. So let's go and let's do one of these right here. So it says you've got nitrosyl chloride, NO, well, NOCl will be nitrosyl chloride, was synthesized in a closed vessel. Okay, so we have nitrogen monoxide, colorless gas. That's a pale green gas, chlorine gas, all right? And it gives you 2NOCl gas. They're all gases. It's good to look at those because if for some reason one was a solid, it would not be included in the equilibrium expression, okay? Or if it were a liquid. Only gas, gas, gas. It has to all be gas, or when we're doing other equilibrium later, all aqueous, 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 aqueous. Anything, if it's all aqueous, anything that's not aqueous is not going to be in the equilibrium expression. If it's all gas, anything that's not a gas, solid or liquid, will not be in, or aqueous even, would not be in the gas expression. Like if if that was aqueous and that was gas and gas, then it would only be the gases in the expression. That, I haven't seen that really happen, but I mean it could. I'm sure somewhere it might have happened in the multiple choice in 80 or 90, 85 years, whatever it is, of AP exams. Okay, so and they give you the pressures of NOCl, NO, and Cl2. They say calculate the value of Kp for this reaction. So first, number one, find Kp. So Kp is equal to the partial pressure of NOCl squared divided by the partial pressure of NO, also squared partial pressure of chlorine to the first power. Making sure I didn't mess up anything there. Squared knuckle over 2 no squared and Cl to the first. Okay, so plug in those numbers and let's find the value for Kp. Now here's where you got to be careful, and I have to be careful with my numbers. It's bookkeeping, just like thermo and like some of the kinetic stuff got to be as well. NOCl is 1.2. Square that. NO is also squared, and it's 5 times 10 to the negative 2. Don't forget to square it. And then the other one is 3 times 10 to the negative 1. 3.0 to the negative 1. And it is not squared, it's to the first power. Okay, so let's find out what is our value for Kp. So it'll be 1.2 squared divided by 5, 10 to the negative 2. 5 to the negative 2 again, and divided by 3 times 10, then, or 0.3, well, or 1 negative, yeah. Looks like it's 1920, 1900 when I do my sig figs. But let me just double check it again. 1.2 times 1.2 divided by 5.0 e negative 2 divided by 5.0 e negative 2 divided by 3.0 e negative 1 gives me 1900. Yes. Now, you don't have to put units. In the book, I think they do, in your textbook, but they do not ask it on the AP. And it would not be so hard to do in this case. Atmosphere squared over atmosphere squared times atmosphere to the first. So you can figure that out. It's going to be atmosphere and negative 1. Looks like in there somewhere. But negative 1, but yeah, atmosphere negative 1 is what it looks like it'll be. But you don't have to even worry about that, okay? So then it says, how would you calculate Kc from this? So we use the equation, and I've got it up here. Hope that didn't distract you when I did the work here. But Kc is equal to the Kp value, which is, I'm sorry. No. Sorry. We know the Kp, so plug the Kp, 1900. Let me just, I hate to write it. I don't have much space. But here, I'll just go straight down here. KC, KP. All right. KP is 1900 equals KC. We don't know KC times. Now, even though there's parentheses here, I like to brackify this because I have a lot of numbers coming into play here. Uh-oh, I'm stepping on some things here. R is 0.0821 liter atmosphere mole Kelvin. Now, we don't have to worry about the units, as I told you about. That, you know, you're used to seeing that on R. Temperature must be Kelvin, and it says at 298 Kelvin. Now, sometimes on the AP, sometimes they'll give you a Kelvin temperature. They're being nice to you. They're tired of seeing you forget to put Celsius to Kelvin so much. But usually, they're not tired of it. Usually, they give you Celsius, so be careful. So it's R times T, and you raise the entire thing to the power of moles, the number of moles of product gas minus the number of moles of reactant gas. So product gas is 2 moles minus reactant is 2 plus 1 mole. 2 plus 1, 3 moles, and 2. 2 minus 3. That means negative 1 power, right? So let's do some algebra stuff here. 1900 equals KC times. So I'm going to take 0.0821 times 298 is 24.5 and raise it to the negative 1 power. Okay. So that's going to be the inverse of 24.5, you know. Actually, just to save space, because I'm going to run out of space here, but 24.5 to the negative 1 power. Now, on the next step, you could, if you wanted to, you could calculate that 1 divided by 24.5, or you could just do this. The next step could say over 24.5, because that's what it is. And then so that means you're going to cross multiply by that number. So 1900 times 24.5 equals 4. It looks a little strange to me. I'm going to double check this. 4, 6, 8, 2 sig figs. 46000 equals KC. Seems like I would have a smaller number, but let me just double check that. 0.0821 times 298. Now, if I do it the other way, it's 0.04. 0.0408 if I raise that to the negative 1 power. And if I divide 1900 by that number, yep, it's correct. 46000 is KC. And you don't have to worry about any units on it. All right. Then it says they gave you KP on letter C. Okay, we'll do this one too. All right. This will be a short lesson, okay? I don't know if it's too short, then I might say, I'll do this and something else too. It's also not one of the most important, as I told you, but it's something that's good to know how to manipulate the values, and that's what we're doing out here. All right, for letter C, it says, all right, the same one we always see. We're going to see this, and we're going to see it more in this chapter. And it says at 127, Kp is 0.0281 for this reaction. Calculate the value of Kc. So Kp equals Kc times, RT to the change in moles of gas. So this time we know Kp is 0.0821. 281. Ah, that's weird. 281. That maybe I made that problem up, or maybe not. It looks so goofy. Okay, R is going to be 0.0821, and temperature is going to be 127 Celsius. There it was. I'm waiting for it to catch you. So make sure you Kelvinize that. And look, and guess what? They like 27 on the AP. 27, 127, 227, they like that on the AP. Because what happens when you add 227 plus 273? You get 400. 127 plus 273 gives you 400 Kelvin. That way you come up to a nice, easy number. And keep in mind on the AP, Multiple choice, if you can't use the calculators, I mean, unless you're doing an online test, I guess you might be able, but you don't use calculators, and so they do give you math. But sometimes the math can be real easy, and all the numbers would cancel. One more thing I'll point out, R is always the gas, liter, atmosphere, mole, Kelvin, 0.0821 in this equation. But there are, by the time we finish the AP, all the material before the AP exam, there's going to be on the AP formula sheet, I don't know, there's probably going to be 4 or 5 equations at least where you see R written in it. And sometimes R is for energy. If R is ever to calculate energy, then remember it's not going to be 0821. Okay, it's going to be, for energy, it's going to be something that says joules. So look at the unit. 0821 liter, atmosphere, mole, Kelvin, that's for gases. These are all gases, okay? But if it says energy, or even energy of gases, be careful. Then you're going to use the 8.31. You'll see that. 8.31 or 8.314. Depending on how many numbers they give you, sig figs. All right, so to do this, Kc. So I'll just, I forgot to put my number up here. So then you raise it to this is going to be 4 moles of product gas minus 2 moles of the reactant. So it's going to be squared. So 0.0281 equals Kc times 32.8 squared. So then just divide that by 32.8 squared. Yeah, okay. Like I said, a lot of times I check my work. I try to quickly check it because I don't know if I ever mess up on a video. Somebody will tell me later, "Oh, Vela, you got that wrong." Okay. All right. But I try to get that 2.61, 10 to the negative 5. That sounds like a more realistic value for Kc. So the problem that came before this, that long number, big number, maybe I made that problem up or something. I don't know. But it can be, that would be true though. It can be a large or a small number. 2.61, 10 to the negative 5 is the Kc. Or, yeah, right, Kc equals that. They normally put Kc equals, not on the right. Okay, but now, look on the next page, and I shouldn't have to say much about this because this is just going to be a review of what you've already seen. It says, calculate Kp. I'm looking at a whole lot of information here, which I'll wait when I do Q, 3, 13, 4. And then we get to the math finally, don't we? Yes. Okay. All right. Sorry, I'm talking to myself. I'm looking at my notes. I was wondering if I'm going to go even farther. But no, I'm going to make this a quick little, there's no need to go into 13.4. It doesn't relate to this. I'm just talking to myself. All right. Calculate Kp for the following at 127. So this is true at 127 Celsius. Actually, I can write it up here. At 127, Kc equals 2.61, 10 to the negative 5. All right. So now it says, what will the value for Kc be? Oh no, Kp. Okay, that was Kp, right? Oh no. I'm sorry. That is Kc, but the question asked for Kp. Oh, 0281. I don't want to mix that up. 0281. Okay. The Kp value. So on C part 2, here's the reaction. Here's the Kp value. They don't want the Kc anymore because they're asking for Kps. Calculate Kp for the following reactions. First, what if we have N2 plus 3H2 gives you 2NH3? Well, I'll just look up here. I'm not going to write it down. So on the first one, what did we do? We take the same reaction that you see up here and we reversed it. So the new Kp new will equal 1 over the old Kp. Okay? So remember that, 1 over 0281. You can be sure that this will pop up somewhere, 1 divided by 0.0281. Oh my goodness, I just remembered something that I did not tell you in the other, or did I? 35.6. Yeah, 35.6. I just remembered something I forgot to record. I might have to add it on to one of the other lessons. Yeah, I guess I will have to. So you'll be like, when you see this later, you're like, what was he talking about? I forgot to tell you one of the little rules about this. So, okay. And I was thinking about showing you here, but I better not. I think it's on one of the old worksheet homeworks that you haven't gotten yet that you'll soon see. All right, what about this one? We take NH3 and 1/2 into and 3/2. Well, what you've done there is, remember, you've divided, but don't think divide. Always think multiply. If I go from NH3 to NH3 or an into to 1/2 into, I've multiplied them by 1/2. So if you multiply by 1/2, 1/2 times 1/2 times 1/2, what do you do to the KP? You raise it to the power of that. So the new K will be, or the new KP new, equals KP old raised to the 1/2 power. Okay? So 0.281 to the 1/2 also means the square root. Now, if for some reason you had to raise something to like the 1/4 power, that could happen. That might not be. Well, 1/2 power, you can also do this. 1 divided by 2, 1/2. 1 divided by 2 is 0.5. So I can raise it to the 0.5 power. On your calculator, there's a button that says x to the y. You can raise x to the y power. But, I won't do it that way. I'll just do square root. Well, actually, I'll do it that way. 0.5. So let's just say, so to get the square root, 0.0281, and I'm going to write x to the y, and I'm going to put 0.5. To the 0.5, x raised to the 0.5 power is 0.1676. Or 0.0281 and get the square root, 0.1676. Okay? 0.167. Just with the sig figs, it's just 0.167. Okay, so that's the new K. And then the last one, 1/2 into 3/2 H2. So now I have just done both things. I've reversed it and I have multiplied by 1/2. So the new K is 1 over the original K P to the 1/2 to the 1/2 power. Okay, because I multiplied by 1/2. So 1 over KP to the 1 over that. I could just use my number there if I wanted to. KP to the 1/2 power is, if I put in 0.0281, I'll just put it in 0.167. I'll just do this to save space. I'm running out of place here. 0.281 to the 1/2 power is 0.167. 1 over 0.167 is 5.99. Is KP new for that one. Okay. You can't see the KP, but KP, there it is. KP new. Yay. Alrighty. Well, that is all. So, hey, 23 minutes. That's pretty quick. So this is a short lesson. We'll see if this gets... The work might be a little longer. So, I don't know. It might take you 15, 20 minutes to do the work. I don't know. I'll see you guys.